And we're going to get started today. So thanks everybody for joining us today here in the DBA Fundamentals chapter from everywhere or anywhere around the world that you might be. The topic for today is Azure SQL Data Warehouse for SQL Server DBA. So I'm going to assume, obviously, all of you guys are SQL Server DBAs and are here in the DBA Fundamentals chapter. And looking to branch out into this very exciting offering from Microsoft. Allow me to introduce myself really quick. I'm a DBA and consultant. I've been working with Microsoft products for 11 years now. I used to work out of HP in Costa Rica. I'm a principal consultant at Pythian in Ottawa, Ontario now. I'm honored to be a Microsoft Data Platform MVP. Feel free to reach out to me at Warchav on Twitter. You can check out my personal blog at sqlturbo.com. If you have any questions and we just don't have enough time to go over them today, feel free to shoot me an email at warner@sqlturbo.com. And if you want to check out my company's technical blog as well, that's at pythian.com. And there's a lot of stuff there, not just Microsoft Data Platform, but from other providers as well. Okay. All right, so the agenda for today, the plan, we're going to cover Azure SQL Data Warehouse. That's going to make it easy to understand and adopt for SQL Server DBAs. Myself, I've been a SQL Server DBA for many, many years at this point, and I try to tailor the material to people that I know are coming from the same background as myself to make it easy to get our heads around the differences in Azure SQL Data Warehouse. All right. We're going to go over why we want to do data warehousing in the cloud, what is the service cost and the model for that service, and as well the difference with SQL Server, and we're going to do some demos for loading and querying the data in the Azure SQL Data Warehouse. Okay. So the only two prerequisites for today's session is basically, I assume that you guys have SQL Server experience, so I'm not going to go into SQL Server fundamental stuff, and I also going to assume that you have some familiarity with basic data warehousing concepts, nothing crazy, what's a fact table, what are dimension tables, and so on. And really, that's all you need to get your feet wet with Azure SQL Data Warehouse. All right. So let's talk about first, real quick, just to get it out of the way. Why should we even consider or entertain the idea of doing cloud for data warehousing as opposed to the traditional data warehousing? And I think it's a very compelling argument, especially for data warehousing, that the cloud just wins hand down. For example, let's think about a traditional on-prem data warehouse. You have to do a significant upfront investment because data warehouses are not cheap to run, right? We usually need quite a bit of storage. We need powerful hardware. So big upfront investment on a traditional project. On a cloud data warehouse, we just have a recurring cost. It can be very predictable. We can even get some savings by using the flexibility of the cloud as well, right? When we need to do forecasting and buy the capacity, so basically spec out our servers, in a traditional scenario, it's very difficult. We have to, guess, pretty much as a guess or estimate really well the amount of cores that we're going to be using. We have to figure out how much memory, how much storage, and yes, obviously we can change that as we go along, but we have to be able to usually give a pretty good estimate to the business, right? In the cloud, we're talking about dynamic capacity, so we can crank up the power when we need it and dial it down when we don't, right? On a traditional on-prem data warehouse, the client has to manage the solution, so obviously you need to maintain the software, you need to maintain the operating system, and so on. In the cloud, Microsoft is already doing all of that. You don't have to worry about it. All you get is a database engine, and that's it. On-prem, you're stuck, or maybe every few months you get a service pack, but for the most part, you have one version of software, you wait a couple of years, then you get another version of the software, and so on. In the cloud, it's continuous delivered, continuous improvements. There are things, when I made the first version of this deck about 4 or 5 months ago, there are things that I had to review already for today, just because they've already been improved by Microsoft since the last time I wrote the deck. So again, every single time Every month they're doing some, they're working on it, and then they're just releasing it right away for people to play with these new features, right? Traditional, the last disadvantage that it has is that, well, you need to complete the ecosystem because the data warehouse doesn't really work in a vacuum, right? There's usually ETL tooling. There's usually might be a analytical layer like an OLAP cube or a tabular model. Then there's the visualization piece, right? You have you can have something like reporting services. You could have something like just Excel. You can have something like a third-party system like Cognos for your reporting and so on. In the cloud, the advantage is that the providers, and in this case Azure, already have all these different pieces, and it's just a matter of connecting them because all these services are tightly integrated, right? So in my opinion, for people that don't have or have a lot of experience deploying data warehouses in the cloud, if they are thinking of doing data warehousing on-prem, it's definitely worth looking into to just do it in the cloud instead, because the difference is, like I said, is quite big. The advantages that you get are just too big not to at least consider it for sure. So obviously, if we apply all that information to Azure SQL Data Warehouse, well, what is Azure SQL DW? It's a service inside Microsoft Azure, so it is a cloud service. It is a successor, let's call it, to the on-premise appliance that is known as the Analytical Platform Service, or also Parallel Data Warehouse. So Microsoft still sells this box basically that they ship to your data center, and they hook it up, and you run the parallel data warehouse software if you want. Again, there's disadvantages to doing that. Of course, you're buying an actual thing instead of just using cloud compute, right? So we can think of Azure SQL Data Warehouse as the cloud version of this data warehousing appliance, but definitely, like I said, I think running in the cloud has its own advantages. The service is definitely targeted at running multi-terabyte data warehousing workloads. So I would say it's at least 1 terabyte because you're charged by in increments of 1 terabyte. So it doesn't really make a lot of sense, for example, to think about setting up a, let's say, 500 gig. If you have a small data warehouse, it's not really even a data warehouse at that stage. Maybe a small data mart. If you're not even approaching that 1 terabyte mark, it might not make a lot of sense because you're going to be paying for 1 terabyte of storage regardless, okay? It is a platform as a service offering. Also, nowadays, it's I would say there's a subset that we can think of as data warehouse as a service, because it's not only Azure that is providing these data warehouse as a service offerings, but AWS also has its own offering. It's called Redshift, and Google as well has its own offering called Google BigQuery, right? And each one of those is definitely out of scope of today. They can be a presentation on its own. The system is massively parallel processing, so it is not just one big box. It is a bunch of different mid-tier, let's call it, powerful boxes that work together to do the querying and processing, okay? So that's really a big difference from running just regular SQL, vanilla SQL Server. It's just you put it in one machine, and if you need more compute power, you just, you add more cores to the machine, you add more memory to the machine, you add more storage to the machine, and so on, right? In this case, Azure SQL DW, we have compute is distributed, so each node has its own memory, its own CPUs, and storage is distributed as well. So the storage layer is independent from the amount of compute that you get, right? And then we're going to go into detail on the slides as to how that's architected. So real quick again, SMP versus MPP. So SMP is what most of us are used to on premises. Symmetric multiprocessing system is just one machine. We set it up with a certain amount of core, certain amount of memory, and a certain amount of storage, and we install SQL Server there, and it runs. So that's the usual vanilla, let's say, SQL Server installation. Azure SQL Data Warehouse is an MPP system, so we're talking about multiple nodes. Each of them coordinate the work that they're doing for a query, and that's how we get that type of performance where we can analyze, a workload that can get to hundreds of terabytes or even on the petabyte range. Right? So real quick here, some architectural pieces of Azure SQL Data Warehouse. So we have a client. Let's start from the left. We have a client, and it does the connection to what is known as the control node. So the control node can be seen as kind of like the gatekeeper and the coordinator for Azure SQL Data Warehouse. Behind the control node, there are other machines called compute nodes, and the amount of compute nodes that are going to be part of your Azure SQL Data Warehouse is variable depending on how much performance you're buying for the service. Now, because it is a distributed system, there is another service that does not exist on on-premise SQL Server called the data movement service. And the reason for it is that sometimes data has to be moved between the different machines to be able to resolve a query, right? Because on a vanilla SQL Server, that SQL Server has access to all the storage underneath it, and it doesn't need to be moving data around to other machines. Whereas in Azure SQL Data Warehouse, maybe a node needs to join with some data that is coming from another node. So we need this behind the scenes service called the data movement service to be able to do this type of operations. Now, it's important to know that it's there because it'll make sense when you start actually working with the system and trying to analyze its behavior, but you don't really have to do anything to it, right? It's not something you manage. The whole platform is managed for you. You don't have to take a look at having to patch or start up or do anything with the data movement service. That's all handled behind the covers. And last, at the very right end, we have this concept of distributions. And this is, again, another big concept that is completely different from SQL Server. You can think of distributions as different buckets of data, and that's how the storage layer for Azure SQL Data Warehouse is architected. It takes the data, and it uses a different algorithm. You have a choice, and we'll go through it in a little bit. It uses an algorithm to say, okay, this record, I'm going to put it in this bucket, and this other record in this other bucket, and so on. And the whole point is to distribute your data around many different buckets so that a lot of work can be done in parallel, right? So each one of those buckets is called a distribution, and the system has 60 distributions. So that's 60, and it is a static number. So you're going to get a bunch of data coming in, and Azure SQL Data Warehouse is going to use an algorithm of your choice, and it's going to distribute it amongst a max of 60 buckets of data. Okay, and that number of 60, it was a number that they came up with at Microsoft, and at this moment in time, it is fixed. It doesn't matter if you have a very small data warehouse or a very big data warehouse. The max buckets there, the 60. Is still basically it's a fixed property of the system. You can't configure a smaller amount or a bigger amount. It's just what it is. Okay. So some very interesting things about the service model for Azure SQL Data Warehouse, for example, is that the compute and storage can be scaled and built separately. So this is different, for example, if some of you have experience with Amazon's Redshift. On Redshift, when you want to increase the size of your cluster, or you want to increase the compute capacity of your cluster, it's tied into each other because the nodes all have local storage. So you don't have the capacity to just say, I want to add more storage, but not add more nodes. It's always, you have to add an entire node with Redshift. So Azure SQL DW does not work like that. You can actually say, I want to increase the amount of nodes and not have an increased amount of storage, or you can keep loading data into the system and thus increasing your storage consumption, but not increase the amount of compute. And this can be very powerful because you can have a workload where you are loading a lot of data, but your compute's not really changing. Let's say you're always just targeting the latest 20% of your data warehouse for the most part, and you have a few queries that go into the older months, let's say, of your data warehouse. So you don't really, even though you might be, constantly increasing your storage consumption, your active working set is not really increasing. So you don't have to pay. You don't want to increase your compute. You don't want to have to pay for more compute that you're not using, right? Compute is measured in this unit called data warehousing units. Now, if you guys are familiar with Azure SQL Database, you're probably going to be familiar with, this concept of units to define performance, and it's all done by Microsoft so that you don't really think in terms of hardware specs. You don't have to really think in terms of the speed of your cores or the amount of memory that you're getting. It's just that you just think of an abstract performance unit, and then you can just dial it up or dial it down as necessary. In Azure SQL Data Warehouse, it's actually very interesting because it's a lot easier to wrap your hand around it than with Azure SQL Database, I find. And it's because the data warehousing units actually control the amount of these compute nodes that you get. So in this slide deck, right here in this slide, we can see, for example, I have 2 compute nodes. Let's say that's data warehousing 200, and then if I wanted to go to data warehousing units of 400, then I would get 4 compute nodes instead, right? So it's a lot easier to understand actually in Azure SQL Data Warehouse. Like I was saying before, storage is built in 1 terabyte increments, so that's why I said it doesn't really make a lot of sense to do less than 1 terabyte because you're going to pay for 1 terabyte at least anyway. And the last bit about the service model that is very important to also point out, because I think it's a big, it is a big draw for medium-sized businesses that maybe in the past could not afford data warehousing, and this is something that I'm seeing a lot out in the field with my clients, is the fact that you can actually pause compute and you don't get charged for it. So that's very interesting, right? So we can have, let's say we have an architecture where I just load data over a window during the night, and then I build an analytical cube, and then my users all go through the cube. In that scenario, you could just run your data warehouse during the time that you're loading, and then running the processing for the analytical cube, and then turn it off, right? And then you will not be paying for the compute during the time that the data warehouse was off, right? So that can be very powerful and a great way to get savings for medium businesses that don't really require a 24/7 data warehouse. Now, big enterprises, as you know, as the user base of the data warehouse gets bigger, and then some people start asking for direct querying privileges and all that kind of stuff, it might, you know, data warehouses eventually evolve into 24/7 operations. But if you don't have a data warehouse that is a 24/7, running with Azure SQL Data Warehouse might be a really good idea because you can actually pause the compute. Okay. All right. Something that DBAs are hold very dear to their hearts is backup and recovery. You don't have to do anything for it. It's managed by the service. They keep backups for 7 days. They make a snapshot about every 4 to 8 hours. There's no exact times. There's a window there. In case of disaster recovery, you can do a geo restore of that to a paired data center. So you'll know that you can recover always up to 8 hours and to a point in time for about 7 days. The only problem right now with the backup story is long-term retention. So if for any reason, I don't know, regulatory or compliance or something like that, because I mean nobody wants to keep backups for data warehouses for a long time, usually, unless you're really forced to do that, because a lot of storage. But if you need to have a copy of your data warehouse for longer than 7 days, right now there's not really a nice solution for it. The current recommendation is to do a restore of the data warehouse and then pause compute. So you're not paying for any compute, you're just going to be paying for the storage for that particular copy. And then at that point you can keep it forever as long as you keep paying for the storage for it. What I'm hoping for in the future is to see integration with like an Azure, with the Azure Backup Vault, and then long-term retention as well, because usually for long-term retention people don't want to pay for the premium storage, right? They just want to pay for cheap long-term storage, right? So I am hoping that we're going to get some improvements with the backup story, but right now, like I said, the issue with the backup story is just the long-term retention. The other stuff, usually what I found is most people are okay with these terms. Okay, so let's talk about how is it different from a SQL Server, okay? So first thing is the distribution method. Like I said, this is the way that Azure SQL Data Warehouse is going to take a record and put it in a different bucket, and then those buckets will get attached to different machines that are part of the data warehouse. And it's really the most important concept to get good performance, because you want to have it done in a way that the system is going to distribute the records in a uniform way to make it really easy for the parallelism to distribute all that power. And you also want to be able to avoid the data movement service doing a lot of back and forth between the nodes, right? So there are 3 different methods. This is the different algorithms that I mentioned before that the system can use to distribute the data. So there's hash distribution, round robin distribution, and now there is also the replicated distribution method. So replicated was not available until probably like a month or a couple of months ago. It's fairly new. It existed in APS PDW, so it was on premises, but it wasn't in the cloud. Now it is in the cloud. So let's go into detail on what each one of these does. So the hash distribution is, if any of you guys that are familiar with hash joins or hash tables, you're going to know what it is. If you have a value of a record, let's say you have a value of a record like country, all the records that are in the same country will end up in the same machine, right? Because let's say we use Canada. Canada will always hash the same value, so they will all end up in the same distribution, right? You want to use hash distribution, for example, if it's used in joins or used in group by in your queries, because then you can save on data movement, right? However, if a particular value is very dominant in the table, then you probably don't want to do a hash distribution. Let's say, for example, that you are thinking of doing this hash distribution by country for a fact table that has orders, but 90% of your clientele is in the United States. So if you choose the country as your hash distribution, 90% of your data is going to end up in one distribution, and that's just going to overload that distribution. It's not going to give you a uniform load on all the distributions, and it's not going to give you a uniform load when you're running queries either. So that in that particular scenario, hash distributing by country would be a poor choice, and you should pick something different. Okay. So very simple, like I said, overloaded distribution. If you pick something like that example I just made of a country like USA, if all your clients are in the USA, then you're going to end up with this problem, right? You run a query, and then all of your data is just in one distribution, and that distribution is attached to one node. And let's say you're paying for a data warehousing units of 400, and you have 4 nodes. Then when you run most of your queries, you're going to have one node that is going to be really taxed, really high, and the other 3 nodes are basically idle, and that's not what you want out of a massively parallel processing system. What you want is most of the time, most of the nodes are doing work, right? Another way to distribute the records is a round robin, as as the name says. Simply, the service goes over the data, picks a record, puts it in one distribution, picks the next record, puts it in the next distribution, and so on. It does not matter what values there are in the records. It will just continue doing that over the 60 distributions until all the data has been assigned to a bucket, right? In this case, because of the way that is done, it is always going to be uniformly loaded, but there's going to be no correlation between the records that are in a particular bucket. So data movement will be required for that table probably in most operations, because there's always going to be some records that are going to be around in different machines, right? A recommendation, if the table doesn't have a good hash column, and it might be too big to be replicated on the entire data warehouse, then that can be a good option to do a round robin. Because and if a value is very skewed and you don't really find another column that you think would be a good hash distribution candidate, then at least you know that round robin will always give you a uniform load of storage in the system. Finally, the easiest one to understand is just replicated distribution that basically just takes the table and puts it on each node. The recommendation is to leave that for tables that are smaller than 2 gigabytes. If the table, for example, is perfect example is a date dimension. So date dimensions are usually not massive. and they're usually very commonly used as predicates, then they're a good candidate because then we can put them on each compute node, right? So the only thing to keep in mind, like I said, and the recommendation is for tables that are small, think about it, right? If you have 4 compute nodes and you decide that you want to replicate a table that is 20 gigs, then suddenly that table is not going to consume 20 gigs out of your data warehouse. It's going to consume 80, right? So it is something to keep in mind, and that's why recommendations to keep it to smaller tables, not big tables, right? There's a bunch of T-SQL differences, so most of it is not that hard to get around, and a lot of the constructs are there. So when I say that there's a bunch, there's nothing to be super scared about. I would say probably 80% of the stuff that you're currently doing on-prem, you can probably do in Azure SQL Data Warehouse. And if you're starting from scratch, then you're probably not even going to miss that much of the things that are not there. I'm just going to go here over the main ones, but the whole list is there on that link that's in the slide deck. There's a construct that is very commonly used. It's called CTAS. It's create table as, and you would then provide a query that materializes the table, and we'll see it in the demo. And the reason why this construct is so popular is because it always runs in parallel, and it always is minimally logged by the system in Azure SQL Data Warehouse. So it can materialize tables really, really quickly. You can't do a join on an update or a delete, but there's workarounds for it. You can do, for example, a CTAS and then replace, or you can pre-join the records that you want to have be part of the update and delete into a temp table, and then use that, and so on, right? Merge is not supported for now, but a merge can always be written as a multi-statement instruction. A statistics creation and update is not automatic for now. I've been told this is being worked on at the moment, so right now the statistics are your responsibility, but there is some improvement being done in that regard. And some of the complex data types that you might have on SQL on-prem are not present on Azure SQL DW at the moment, like geography, geometry, hierarchies, or XML. So if you are thinking of warehousing these types, then you can probably bring them in as binaries, but you won't be able to use like the functions or the analytical functions that you're used to using them when you're working with them on-prem or on just vanilla SQL Server, okay? All right, so let's take a break here from the slides. I'm just going to show you guys the portal experience and some quick metadata that we can get from the service once it's up and running. So I already created a data warehouse before the session today. So I'm just going to show you guys real quick. Data warehouses live inside SQL servers, Azure SQL servers. So you can see here I have my warehouse. It's online right now, and it's using DW value of 100. And the portal experience for data warehouses is very similar to what you get for Azure SQL database, right? So you have your server name, you can get your connection strings, you can actually increase the scale for your data warehouse. For example, you can see here I'm on my performance level 100, and it's going to give me an estimate of how much I've used. Obviously, I just created this warehouse today, so I haven't used much of it. And then you can increase here, and it'll give you an estimate of pricing based on your currency. So I have it in Canadian dollars, so that's what it is. So portal, like I said, if you guys are familiar with the portal, then it's going to be a very familiar experience for you guys. The biggest difference also here, if you look at the top, it's something that Azure SQL Database doesn't have yet, and it's the ability to pause, like I mentioned. Let's look at some of the metadata that we can get. So I have a VM that I've already whitelisted on the firewall there for the server, so I can run this stuff and show you guys real quick some of the stuff that we get when we connect to Azure SQL DW. So first, if I run a select version, you guys can see I am running SQL DW, and you can see the versions do not really go with the same number in a SQL Server, right? So right now, SQL Server 2016 is version 13 of the software. The next 2017 is going to be version 14 of the software. Azure SQL Database is version 13 right now, or I think you can also opt into the public preview of version 14. So this is totally different, fork different version numbers completely, right? This is right now, it's version 10. We can see, once you are actually running the data warehouse, we can actually see how many nodes we get as part of our data warehousing units. So I'm running the cheapest one, right? I'm just running a data warehousing 100. So I actually only get one node of each type. So this data warehouse as is right now, it's fully functional as a Microsoft Azure SQL Data Warehouse, but it doesn't, it's not doing distributed compute because I only have actually one compute node, if you guys can see here. And every single SQL DW gets one control node as well, which is the one, like I said, the gatekeeper one. Okay. Something else that is interesting, and we can actually get, again, an idea of how the systems are configured. We can actually look at the schedulers here for the system. And you guys can see here, each node has a different ID. So this is node 1, and then the other one is node 2. And we can see there's 6 schedulers. So basically we have let's say 6 cores. We don't really know because we don't have visibility to say if they're physical cores, logical cores, or what they are. But we know that there are then six cores on each node that we can send queries to. And again, this is all really for curiosity because, you know, I know as DBAs we always want to check out what's running under the hood, but there is no actual button or anything that you configure for this metadata that I'm showing you guys right now. And then finally, again, just for the sake of curiosity, you can check how many threads are running on each one of those nodes. And I can see, for example, on my compute node, I have 155 threads. On the control node, I have 250 threads. Again, that's just pure curiosity to just check out what's going on under the hood. There's nothing you can configure there for that as well. The system all handles that kind of stuff automatically. Okay, so let's go back into the slides and let's talk about some recommendations for warehouse design if you're going to use Azure SQL DW. Again, like I mentioned before, if your service is at 1 terabyte plus, then it's a good choice. If you have a workload that you have already been doing using column stores, then it's definitely going to be really easy because the default table type is clustered column store. The ideal column store segment, remember, is 1 million records, same as SQL Server. It's actually like 1,048,576 records. Easier to just say 1 million. SQL Data Warehouse uses 60 distributions. So again, this is a fixed number, but it actually comes, sorry about that, it actually comes into play, this number of 60, and I'll show you guys how later on in an example that I have. And the classic design for SQL DW is to do fact tables as column stores, optionally with partitioning, so we can mix both. And if you do have a good column for hash distribution, that's what you want to use as much as possible because we want to minimize data movement. For dimension tables, it's usually a B-tree table, or if it's a really large dimension, you can use a column store. Again, if there's a good candidate for hashing, you can use that. If not, and it's a small dimension, then do replicated, and if not, you can always just do round robin. Okay. Now I'm going to show you guys how this 60 distribution thing comes into play and how partitioning works a little bit different. Not really that it works different, it's just that you have to think about it in a bit different way with Azure SQL DW. So let's say on-prem is not that, some people have daily partitions, but that type of scenario does not translate, might not translate too well to Azure SQL DW, and I'll show you guys why. So let's say we have 365 partitions because we're partitioning by day, but at the same time we have 60 distributions, right? So that means that total Once we take those partitions and we distribute it into 60 buckets, then we have 21,900 partitions total as part of the system. So if we know that the column stored table is the best way to store things in SQL DW, and we know that we want to get 1 million records in each segment to get optimal performance, then that means that for optimal performance, if you're going to be partitioning daily, you need to have a table that is at least 21 billion records, right? And that's quite big. There might not be that many tables that are that big in your data warehouse, right? So that is really the issue. The fact that we have a distributed system explodes the size that the table has to have to be really considered like it's optimally stored. So partitioning, usually we move it to a higher granularity, at least at the week or monthly level or quarterly level even, if necessary for DW, because things, they start to get a little bit better. So if we have, let's say, monthly partitions, then we have 12 partitions, so we have 60 distributions, so that puts it into 720 partitions total. Again, considering that 1 million is the optimal, then it's not 21 billion records, now it's down to 720 million records. That's still a big number, but that looks more to something that could be as part of fact table in a data warehouse and not as large as the 21 billion. If we move it even to a higher granularity, let's say to quarterly, then we go into 4 partitions, then we go into 4 times 60, that's 240 partitions, and now we're talking about 240 million records instead to have that table be optimally stored, right? So think about that, just partitioning, keep in mind you want to make sure that you do need it, and you can do this quick math to figure out if you're going to be able to actually store it optimally or not, okay? Now we're talking about data loading, because then we're going to switch over to the demo for loading data, and there's really 2 ways of loading data. One way is done through the control node, so through a basic SQL connection, and then the other one is Polybase. And Polybase is basically a data loading software that lives inside SQL Server and can do really fast parallel loads from storage, right? So through the control node, it's kind of like the same way that you would load your data today with SQL Server. So you would just connect, let's say, to an SSIS and create a target, and you just load your data through that. Or you can BCP and you can connect to the control node and you just BCP your data in. And that, what it does is that it flows all the data through the control node and then through the distributions layers underneath, right? Now Polybase can load from blob storage or Azure Data Lake storage. And the difference is that it does a parallel multi-threaded load that does not go through the control node. It goes straight from the storage through the distributed compute into the buckets, right? So usually the loads with Polybase are way faster. And if we're talking about multiple gigabytes that you're loading, I mean, if you're just loading, let's say 5,000 records, you just want to do a quick BCP in, that's going to be fine. But if we're talking about loading gigabytes, definitely about loading terabytes of data, Polybase is the way to go, right? Because what happens is that in these bigger, larger data loads, the control node becomes a bottleneck itself, right? Because it does not load the data through the distributed compute nodes, and it doesn't load it in parallel. It just loads it through the control node, which again can become a bottleneck for large data loads. So I'm just going to show you guys real quick. Let's switch again here in demo mode and load some data with Polybase. So I'm going to run here through the prereqs. I already did all these before the demo, so we can just go through them. So you have to create a master key in your database, and the reason for that is because you're going to have to create a credential to connect to the storage. And this credential, you can get the key from your portal for your storage account. Now that we have that credential, then we create an external data source. So this is a storage account that I have, and I say, look at here, it says type Hadoop, but it's not really Hadoop. It's just basic blob storage. But the reason why this is type Hadoop is because Polybase was originally developed to load data into SQL Server from Hadoop. So that's kind of like a legacy thing here where I have to specify Hadoop for warehouse storage. And then I mentioned my credential that I already created. Once I have that, I can create an external file format. So I'm basically telling Polybase what is the format that I'm going to be loading the files as. In this case, I'm using CSVs, so pretty straightforward. And if there are dates, I have to specify how to expect that date is going to come in as. Okay. Now, the interesting way, or how we are going to get that data actually in, is through this construct of an external table. So I'm going to define this external table, and it has all these different types, and I specify where it's coming from. So this location is basically, you know, what folder out of the data source that I just specified using that format. And there's a couple of different settings here that we're not really in scope to go into what they do, and as to how the system behaves for values that get rejected. Okay. All right, and now that we define this external table, you use the CTAS, again, that create table as construct to actually bring it into the data warehouse. So I'm gonna run this because this is the part that I didn't do previously, so that I could just run it through the demo. And that is going to go into my external table definition and actually materialize it inside the data warehouse. And I also have a query here where we can monitor what it's doing under the covers. So you guys can see there's a bunch of different processes doing a lot of work here. So I don't get just one connection line trying to load it. I actually get a bunch of different threads. They all say they're writers, they're doing bulk inserts. The system also gives you a measurement of how they're doing in terms of performance. You guys check here at the very top. So you can see how many bytes are being processed by each thread, how many rows they've processed, and the speed at which they are being processed, right? And let's see what else we have here. Oh, and it also gives you the destination info. So it tells you which distribution is it going into. So you guys can see here as well, the thing that we were talking about before is see all the different numbers here of the distributions and up to the number 60 there, okay? All right, so it looks like it completed, which is pretty good. Lasted in, it was in 1 minute. And then we can actually just run a dbcc command to see how the data was distributed, right? So if you guys see here, we have records from 1 all the way to 60, like I mentioned before, right? You can see it all here at the bottom. And you can see that in my case here, if we look at the different amounts of records on the query, we were distributing by the product key. And if we look at the results, just a visual confirmation, we can see that most distributions have somewhere between 500,000 to 600,000 records. So the table is not big enough at this point to really fill up each distribution to its minimum segment ideal size of 1 million, but at least the product key, we know that it's very uniform. There's no huge deviations. Oh, sorry about that. Let me close this down. There's no big deviations in let's say 10 distributions have all the data, and then the rest of the distributions are empty, right? So, all right. Let's switch back over to the slides. And we got about 10 minutes, so that should be enough to finish off. Okay. Now, querying data, it has a little bit of difference. Main difference is that there are some concurrency limits that are on the system depending on the data warehousing units. And there are also some transaction size limits, again, based on your data warehousing units. It's kind of like a built-in resource governor, if you're familiar with the resource governor in SQL Server. So each user gets assigned to a resource class, and that kind of defines how many resources the data warehouse they can get. Another difference querying data has is that some of the DMVs inside Azure SQL DW actually keep historical information, right? So before the query store feature came out in SQL 2016, most of the execution info of SQL Server, it was like capture it while it's happening or go to the plan cache while you can. After that, it's gone. So there's a bunch of the DMVs in Azure SQL DW that actually keep historical info. And then there's also a very, very handy feature that I kind of wish existed on SQL Server, and it's called query labels. And it's basically like exactly what it sounds like. You put a label on a query, and then you can just query these views based on that label and really quickly get to the query that you're interested in, right? So here are the concurrency limits. So you can go from 4 all the way to 32 concurrent queries in Azure SQL DW. If you go over those limits on your current level, then basically it's just, gets queued. You go into a queue, you wait until one of them finishes execution, and then it's your time to jump on. Resource classes, it goes all the way from small to extra large, and the memory there you can consume all the way to 12 gigs per distribution. So if you multiply that by 60, that gives you a really, really large amount of memory. So memory is usually not the biggest concern, I would say. It's usually the concurrency limits, okay? And here's the concept there of query label. And like I said, it's just very straightforward. It's basically a hint. It's an option, and then you just put a label on it, and you can track what your query is doing based on that label. So I'm just going to show you guys real quick how that works. So let me see here. I have the query. So same query there. You guys see here, I'm just providing this, option label. Oops, sorry about that. Forgot to put the schema on it. We execute it, and then we get the value back. And then the cool thing about the query labels, again, is that I can come in and see what happened based on that label. And there's different views at different levels. So at the individual request level, I can see what this query did based on the label. So if you guys see here, my first one was the failed one, which is the one where I forgot to put the schema on it. And then the second one here is the completed one, and it shows you the command that you did, the resource class that got assigned to it, and the time that it took to run it, right? There's also, you can also monitor it at the worker level. So this goes into way bigger detail as to what the actual query did. So you guys can see here, there's a lot more detail going on here. And it actually tells you kind of like what it did to resolve your query. So let me go in here, and I'm going to zoom in. So, because remember, this is the distributed system, right? And I asked for a summation of a table that is distributed amongst a bunch of different tables. So we can see what it did here. It was actually running the aggregation on each one of those distributions, and then putting that as a result inside a temp table that is then going to aggregate again and bring it back out as the final result, right? And all this happens right under the covers. And this is a very simple table. You guys obviously can appreciate how with a very complex query, you can look and see what it actually is doing under the covers and then try to optimize that. And then finally, you can do something similar, but it's at the distribution level, not at the individual worker level. So for example, here for this particular query, we can see what it did at on each distribution, right? So like I mentioned before, it created a temp table, then it ran this aggregation, and then at the end of the query, it just drops that temp table that it used to store the result of the aggregation. So pretty neat stuff, like I said, because these views will keep this information. I believe they will keep up to 10,000 records, and after that, the oldest ones will just be starting to get replaced by the newer ones. But very handy for troubleshooting, because you can go after the fact and see exactly what the system was doing, even though you might, maybe you didn't have a monitoring or anything put on at the very beginning. Well, at least you can use these views to go after and see what was going on. And you can get it at the different detail levels here, like I said, in request level, at the worker or thread level, and at the actual distribution, you can see what it was doing on each one of those 60 distributions. Okay, so there's the demo that we just did, and that's about all the material that I had. And we actually have a few minutes still here for questions. So Shane, I don't know if we have stuff, but now it's a good time. We actually have a few minutes.
Sure. I think, well, first of all, thank you for the presentation and laying it out so clearly. I actually think that most of your presentation did answer most of the questions, but we're getting a few in. So first of all, somebody wants to know, how do you actually create a label? So if you want to go back just to syntax or what you did, just to show them again.
Oh yeah, so for sure, that's pretty easy. So that's all you do. This thing here where it says label equals, it's a completely free text field. You can call it whatever you want. You don't have to predefine to say, oh, this query is assigned to this label, or you have to say, oh, these are the only valid labels. It's completely free text. So it's really up to your developers to define what the labels can be. It can be really handy, for example, to have a standard. Actually, it's a good question, because we can talk about that. It's not a bad idea to have a standard for the labels, because, for example, let's say you can put labels on anything, even on polybase instructions, right? Like I did. So you could say, okay, guys, every time that it's just a query to load data, then we're going to use load underscore the label, or load dash the label, or something like that, so that then you can run reports and just do a, like load percentage type of thing. Same with the queries, right? You could say maybe there's queries that are for procurement fact tables or procurement reports, and then you can use the code like proc underscore, and then you can easily report off of those as well. So there's a couple of cool things there that you can do with labels, definitely.
Cool. That actually makes sense. I suppose it's all kind of persisted as well. You can't change a label, or you can't change the information stored with the label once it's been labeled. So you can't
exactly.
say,
Once it ran with that label, that's it. Yeah.
Yeah, that makes a lot of sense. Someone is asking about query store with Azure SQL Data Warehouse. Is that an option, or is that not an option?
No, there is no option for query store, but yeah, it would be nice. It would be nice, but there is no option yet. I haven't heard of any work on that direction either, unfortunately.
Yeah, well, no, fair enough. I was kind of surprised about the statistics, but as you said, they're working on it, so that would be nice as well.
Yep, that is being worked on.
Okay. We do have a question. Do you know the market share of SQL Data Warehouse versus Redshift?
Oh, I don't know the market share. I'm pretty sure Redshift probably has a larger market share right now, just because Redshift has easily at least 3 to 4 years head start on Azure SQL DW, right? So just based on time alone. Yeah, it's quite a bit of time. So just based on time alone, it's definitely got to have a larger market share. But Redshift has its own downfalls as well. So it's really just a matter of your use case and to what you want to do with your data warehouse. If you're looking, like I said, for independent compute and storage, you're not going to get that with Redshift. If you're coming from a SQL Server-based data warehouse, you probably will have a way easier time migrating it to DW than to migrate it to Redshift and so on, right?
Yeah, fair enough. There is a question here, and I kind of want to ask this myself. At the start, you said you opened up all the firewalls and stuff like that. We have a question here about what connection strings do you use from SQL Server Management Studio or BIDS?
Oh, yeah, sure. So let me show you guys here. So you can get the connection string from the portal. Yeah, I'm just going. So you can get it from the portal, you can get a connection string. This is, for example, the ADO.NET. And if you guys look at it, it's pretty much the same as SQL Server connection. It even uses the same default port, if you guys can see here. I'm not worried if anybody here thinks it's going to hack me or something anyway, because it's like a fake data warehouse, so no worries about that. But yeah, so this is the server name. It's just a TCP endpoint, yeah. and that's it. So that basically you just specify that as a server name and use the same default port, and you have a user ID and a password. The firewall bit is just if you're familiar with Azure SQL Database, is the server itself has a firewall, and you need to open the IPs that are going to go to it, right? So that's where that piece comes in.
Oh, lovely. Question here as well is, for the distribution, which one do you prefer? So do you prefer the hashed or the round robin or the replicated? Or is it kind of a case of it depends?
Yeah, so it's not really a preference. It's about what you get with each one of them, right? So whenever possible, if you have a column that is used a lot in joins and is used a lot for aggregation and grouping, and it also distributes uniformly. So it's a lot of ands, I know, but they exist out there. If you have something like that, then what you want is to hash join, to hash distribute, sorry. Because you always want to have a minimized data movement, right? And data movement can be a killer for the performance of a distributed system. And this is not just Azure SQL DW, any distributed system that has to do data movement, it is always going to be a bottleneck, right? So you want to minimize that. So if you do have a candidate, a good candidate for hash distribution, that should be the first thing you should look at. So the flow of analysis should be, do I have a good candidate for hash distribution? If the answer is yes, then that's what you want to do. If the answer is no, then you have to look into distributed through round robin or through replicated. And then the flow there will be, well, is the table smaller than 2 gigs? And is it used for joins and predicates? And this is used for simple join predicates like inequality or equality. Then if it is smaller than 2 gigs and it's used for the joins and predicates, then you probably want to go with just replicating it so that you don't have to worry about it. It will not do any data movement. It will always be local. And last, at that point, if you fail those two tests, then you just have the last choice, and it's to round robin it, right? And round robin, like I said, it's always going to give you data movement, but at least it has the saving grace that it's always going to also distribute uniformly across all the distributions, right? So it has its ups and downs. But following that kind of like a decision flow, you'll always arrive at one port one way or another, right?
Fair enough. I know it's the top of the hour, and we are starting to get all the thank you, Warner, for the great presentations, kind of flooding the question screen. So I'm just going to ask like one more that came in.
Okay.
Is it possible to add a composite primary key as the hash distribution?
So it's interesting. So you can only hash distribute as one column, and it's not. So that's something that I didn't go into on the slide deck because it's just, again, it's kind of hard. It's like a fast track data warehouse for in 1 hour, right? But the Azure SQL DW will not enforce primary keys. So that's already one thing where it's not exactly the same anyway. And this is not just Azure SQL DW. Any of the distributed systems like Redshift or Google BigQuery or Azure SQL DW, none of them enforce keys. And the reason for that is because it would be prohibitively expensive in terms of performance to check for uniqueness of anything or to check for foreign keys, for example. So to answer the question, first of all, you can't even have primary keys. But second, I do get what you're saying, and it's thinking that, well, I'm going to be joining on these 2 different columns, so I want to distribute by that value. And the way to do that is to do a dirty trick, and is to just create a column yourself and do something like concatenate the values, for example, or
so
add the values, or you basically come up with some sort of computed column. You can compute it yourself when you're loading through Polybase and distribute based on that. So out of the gate, no, but you can work around it. It's not too bad.
Yeah, okay. No, that's perfect. That's fair enough. Yeah, there's still questions coming in, but I think we're going to have to leave it there. We're already 5 minutes past the hour and that. Thank you again, Warner, for the presentation.
Well, I'm excited that people thought, they have questions. That means that there's interest, which is always good, right? So I'll share the slide deck with you, Shane, or you guys will see the recording. You can just check the bio slide, and you have all my contact info there. So if anybody wants to shoot me an email, or a tweet with questions, just feel free to do so. I always respond at usually, at most in one day or not.
That's perfect, and no worries, we'll do that. We'll have the recordings and the slides up, and I think we probably link to your blog and Twitter as well, just so I can get in touch with you. Also, we'll send the questions from this over to you in case people find it useful to write a blog post or just get in touch with people and say, here's the answer to your question. So
Cool,
we'll do that.
cool. Sounds good.
Sounds great. I just got 3 more things to say, just kind of clean up the housekeeping, and I'll let you go. Now, there is a contest for a discount code with DBA Fundamentals. We will be trying to give away a $500 Amazon gift card to one person drawn from the list of users. So keep using that code if you can for the SQL Pass. If I just check my thing again, I think the code is VC15GBQ6. So there is a competition with that for Amazon gift card. We're also trying to give away at least 1 and maybe 2, depending on how many people we can get to use the code, free Comps 2 Pass Summit in September. So we'll see what we can do now. So sign up for the September sessions. And finally, we actually might be looking for another person to help out with the chapter. So just promoting the chapter, again, help behind the scene of administrating. So we will be, if you have any interest in all, just send an email to dbafundamentals@sqlpass.org and we'll try and get in touch with you. Or else hit us up on Twitter @dbafund. And that's it. Warner, thanks again. That was a great presentation, I really have to say.
Awesome. Thanks, guys. And I'll catch you on the next one.
Definitely. Thanks a lot, everyone. Talk to you again.
Bye.
Bye.